experiments on the Work-Energy Theorem by an object are selected to complete this assignment project. According to the Work-Energy Theorem, the net work done is equal to the change in the kinetic energy. The relation between the net work done and the change in kinetic energy is called the Work-Energy Theorem or Work-Energy Principle. If we know the value of the net work done on an object, then the net work-energy theorem can be used to calculate the change in speed of the object. The work-energy theorem tells us how a force, by doing work, can provide kinetic energy to an object or remove kinetic energy from an object. First, to examine the conversion of work into kinetic energy. Second, investigate the validity of the work-energy theorem when velocity of an object is measured with constant distance. Third, to describe the relationship between the work done on an object and the kinetic energy of the object.
We will go to procedure for this experiment. Alright, first open the Physics Bu Edu simulation application and then go to search and then type the simulation list. Next, click on ball on a ramp to run the experiment. Then, the base of the ramp was set about 100 cm. Later, the head of the ramp adjusted to about 10 cm. Next, click on play and then the ball will automatically moving downward on an inclined plane. And then, the time taken for the ball to reach downwards were then recorded. And finally, step 5 to 6 were repeated for head 20 cm and 30 cm. Okay, for 3 head we use 10 cm, 20 cm and 30 cm. For the first one is 10 cm and the first trial here we get 1.47 second. And then we reset, we do for the second time. And here we get about 1.45 second. And lastly, for the third trial, we reset again and we play again. This time we will get 1.46 second. Okay, next we will do for head 20 cm. Okay, for the first trial, the time taken is 1.07 second. And we reset again, we repeat for the second time and we will get 1.09 second. And lastly, for the third trial, we will get also 1.09 second. And lastly, for head 30 cm, for the first trial, the time taken is 0.91 second. And next we repeat again for the second time. This time we will get 0.89 second. And finally, for the third trial, the time taken is 0.91 second. And that's all for the results.
A record of result from the experiment. For a hedge of 10 cm, the average time for the ball to fall down is 1.46 seconds, and for 20 cm, time taken of ball to reach downward is 1.09 seconds, and for 30 cm, time taken of ball to reach downward is 0.91 seconds. We're using this for formula to find the velocity. X is displacement and t is time, so x will divide by the time of interval of the displacement. Velocity for h of 10 cm is 0.68 meter per second. Next, the velocity for h of 20 cm is 0.92 meter per second. And for h of 30 cm, the velocity is 1.10 meter per second. In the Work-Energy Theorem, is defined to be translation kinetic energy. Translation kinetic energy of the mass moving at a speed. So we use this equation to find net work. For height of 10 cm, we got 2.31 times 10 to the power of negative 3. For h of 20 cm, we got 4.23 times 10 to the power of negative 3. For h of 30 cm, we got 6.05 times 10 to the power of negative. This is the graph based on the result. The increasing of h of the ramp affected the time taken of ball to reach downward velocity and the kinetic energy. The added of h of the ramp decreased the time taken of the ball to reach downward. As you can see here, the pattern is decreased. The kinetic energy and velocity of the ball to reach downward increase as the h of the ramp increase. You can see the pattern of both kinetic energy and velocity is increased.
In the experiment, as you can see, there are three variables that measure and observe. Height of the ramp is the manipulated variable, while net work done by the ball is measured variable. And on the other side, we stick the value base of the ramp about 100 cm and also the mass of the ball about 10 gram. From the results, we can see that the time taken of the ball to reach downward is decreased due to increasing height of the ramp. The height of the ramp for 10 cm recorded 1.46 seconds to reach downwards, 1.09 seconds for 20 cm and 0.91 seconds for height of the ramp 30 cm. We also can say that time taken of the ball to reach downwards influenced by the distance of the ball. If we look at the formula of the velocity, we can see that distance or change in the position of an object divided by the time. So this proves that when distance of a ball is increased, time taken of the ball to reach downwards is decreased. We already know that net work done is equal to kinetic energy and also equal to 1/2 mv squared. The velocity of a ball for each height of the ramp is calculated, but before that, the unit of a distance is in cm. So we have to convert the unit to meter due to SI unit. We also already know that 100 cm is equal to 1 meter. After that, substitute the value of time into the formula. 1.46 second, 1.09 second, and 0.91 second. As we can see that the velocity the ball of each height of the ramp for 10 cm is 0.68 meter per second, 0.92 meter per second for 20 cm, and 1.10 meter per second for 30 cm. Kinetic energy is calculated by using the formula 1/2 mv squared after finding the velocity each height of the ramp. Before that, the unit of mass have to convert into kilogram due to SI unit. Kinetic energy of the ball for 10 cm is 2.31 times 10 to the power negative 3 joule. 4.23 times 10 to the power negative 3 joule for 20 cm. 30 cm is 6.05 times 10 to the power negative 3 joule. As we already know, kinetic energy is equal to work done. So, work done for 10 cm is 2.31 times 10 to the power negative 3 joule. 4.23 times 10 to the power negative 3 joule for 20 cm. And for 30 cm is 6.05 times 10 to the power negative 3 joule.
a conclusion, the higher the object is positioned, the greater the velocity and net work done produced by the object. So, the higher the potential energy form of an object had to achieve, a higher the kinetic energy.